Thank you.
Thanks. I will probably stay here. Okay.
Hi, everyone. Thank you for this opportunity to be here today to talk to you about enabling the future of fossil fuel chemical industry by energy automation and software triad. I'm Yasmine McColl. I'm a global business development leader for Schneider Electric for the chemical segment. I'm here with my colleague Maksim Ageev, regional segment leader, and we will be covering this presentation together. So before I get started, let me give you a quick overview of what we're going to be talking about today. First, I'll give you a quick overview of Schneider Electric. If you don't know us, hopefully you will have a better understanding of what Schneider does and what we do in this space. Second, I will give you an overview of industry challenges and drivers, our sustainability triad, and decarbonization pathways and use cases. And at the end, we wrap it up with some questions and answers. Schneider's commitment to sustainability is so strong that we have been #1 sustainable company in the world for the past few years. When it comes to ESG, we play from both sides of the equation. We have adapted ESG goals in our own ecosystem, so we lead by example. We want to be your digital partner for sustainability and efficiency. And today, the business challenges, especially when it comes to sustainability, are so complex, so we have to collaborate. By that, we go out and make partnerships happen, and 60% of our revenue in the industry is done through partnerships. We have a unique business operating model, so we can really drive the sustainability goals forward. We are an energy management company and an industrial automation company. But all of our solutions are integrated by one Schneider. We have multi-hub operations around the world so we can be closer to our partners and our customers. And again, when it comes to ESG, we lead by example. We have adapted ESG goals in our own ecosystem, and that's how we have been #1 sustainable company in the world for the past few years. Our purpose is to empower everybody to make the best uses of the energy and the resources. So now let's talk about sustainability when it comes to chemical industry. Digital was the first disruptor in sustainability. Today, we have data available from all of our assets and operation. We have access to big data. But data by itself is meaningless. We need to make contextual data available and use artificial intelligence to use the data to our advantage. Digital is a key component to drive sustainability. By using digital tools, we make the invisible data visible, actionable, and measurable and actionable, which can be a key driver for sustainability. The second key factor is energy. Energy is the greenest type of energy, electricity. By using electricity, we can decarbonize our processes. But the key is to have access to green energy. And we know today the demand for green energy is high, so we can enable our customers to get access to energy mixes for different types of green energy. So in summary, we can use digital to make invisible data visible, measurable, and actionable, and we can use electricity to decarbonize our processes. We have implemented our own digital tools and our solutions in our own factories, and we were able to increase the efficiency of our own factories by 30%. But investing into digitalization is not enough. We also need to continue to innovate, and especially when it comes to circularity, and make our industries more circular to address sustainability issues. As I mentioned, electricity is the fastest way to decarbonize, but we need to enable our customers to have access to green electricity. So when it comes to the chemical industry has its own challenges. Some of the key challenges that I want to highlight for you today is having access to big data. As I mentioned, today we have data from our assets and operations available, but we need to put this data in good use. We need to use artificial intelligence and contextual data to put the data in good use and enable the next generations to continue running the plants in a more modern way. 94% of our customers in the chemical industry were impacted to some extent by supply chain issues during COVID-19. Our customers want to have more reliable and more efficient supply chain and processes. And then when it comes to CO2, we know the chemical industry and the heavy industries get always scrutinized for emitting a lot of CO2 into the atmosphere. So we need to help our customers to decarbonize by lowering their CO2 emissions through process electrification and creating KPIs and help them to use the digital tools to monitor their CO2 emissions. Also, lastly, but very importantly, this industry is going to have over 2.4 million work shortage by 2028. So we need to be people focused. We need to use our technologies and our digital tools to help our employees to get trained and be able to backfill some of these jobs with technologies. Once we understand the industry challenges, we can help our customers and enable them to address those challenges by using our tools and technologies. Our customers want data-driven decisions. They want to have agile and reliable operation. They want to have access to performance and innovation. And most importantly, they want to transform their businesses for sustainability. At Schneider, we're able to enable our customers by getting access to contextual data and put those data in good use and create KPI dashboards to monitor their business and operation. We can help our customers to have access to agile and reliable operation through digital tools and be more people-focused. Through our digital twin and our partners and our solutions through digital, we can help our customers, enable them to have access to innovation and enhance the performance of their assets. And lastly, when it comes to sustainability, using the technologies such as process electrification and digitalization, we can help our customers to lower their CO2 emissions and electrify their processes and use electricity instead of fossil fuel in the processes to lower their CO2 emissions. All these technologies that I've mentioned to you so far, they are proven and available in other parts of the industry. There are anywhere from AI, machine learning and analytics, cybersecurity, virtual reality, artificial intelligence, big data, and cloud. They are proven and available. We just need to use them in the chemical industry. When it comes to digital transformation, a lot of our customers are deploying some sort of a digital transformation program for their plants. 57 of our customers say that by deploying some sort of a digital transformation program, they're able to see the results in 2 to 3 years. 40% of our customers today, they have some sort of a digital transformation program about deploying in their operations and in their business. So with that, I want to bring you back to the triad. To drive sustainability, we need to think about software. Software enables our customers to make their processes more efficient from an engineering point of view and also from an operation point of view. Automation. Innovation around automation enables our customers to make the most use out of energy. And then when it comes to energy optimization, technologies such as process electrification is a key way to help our customers decarbonize. At Schneider, we're moving towards a more software-centric process automation. And with that, I will pass it on to my colleague Maksim to talk about decarbonization pathways.
Yeah.
Thank you, Maksim.
So, and then when you face you need to understand what is your roadmap for the decarbonizing or defossil fueling the plant. We've done multiple projects, and we've concluded that we should deal with the different waves of implementation. So there are always like what we call wave one of technologies you could apply to reduce your carbon footprint, and we call them no regret moves. So they usually include some incremental energy efficiency measures, like some software and controls, like Yasmine was telling you about. Also some usage of VSDs. You will be surprised that VSDs are well-known technology at the market. There is still room for applying VSDs in the different types of applications, and with a good payback. Then there could also be some green PPAs applied, and these are usually like immediate cost saving and carbon footprint reduction actions you could take with a short term risk mitigation. So there is not much risk on the technology as well. Then what we call wave two, which are more mature moves to reach the sustainability or net zero targets of the company, and they usually include some more or less significant hardware refurbishments and more energy efficiency initiatives, like for instance heat recovery, compressors replacement with electrical ones or more efficient ones, some fuel switches, boiler upgrades, and some more complicated systems. And these are the projects with usually with the more capex investment required, but also bringing more significant reduction of the CO2 footprint. Then we've been talking today already about some new technologies. We believe that these are what we call big bets to reach net zero, and there is no way to achieve net zero without putting some resources on the big bets. But these are more what we call wave three, where you need to deploy some transformational levers to reach net zero. And this transformation really means that you are if you're talking about chemicals, it's sometimes changing the business model, sometimes changing the energy landscape of the plant, sometimes changing the production mix of the plant. So these are quite strategic decisions to be taken, and also all of these technologies, they are somehow new in terms of deployment. So a lot of technological risks companies need to take, which technology to choose. So it makes sense to start with some pilots, which we are showing here. And we are working on some pilots for carbon capture, utilization and storage, hydrogen, and for instance, full heat electrification. But this is more long-term mitigation, and without these transformative initiatives, it's not possible to achieve net zero, especially in the carbon-intensive industries like chemicals and petrochemicals. So what is also important to mention that, in our opinion, effective decarbonization, it requires an end-to-end process and technology. What does it mean? Here you see the example of naphtha to olefin, one of the examples for naphtha to olefin, and it's still simplified example. So you see that to achieve net zero at the plant, you need to consider all pieces in the value chain of the plant, starting from energy sourcing, energy production. We saw the presentation of Ion talking about decarbonizing at the energy production side, then energy consumption in plant, and also energy sales. So all of these should be considered when taking decision on the roadmap for the net zero. And for each of these steps of the value chain, there are no regret moves, mature moves, and transformative initiatives chemical company could take. And you can see some of the technologies applicable for each of the value chain pieces. and this list, this example is not exhaustive. It's just to illustrate that that there is a complex task to decarbonize the process plant, and you need to consider the end-to-end process and technology. So normally, companies which would like to develop that kind of roadmap, they need to consider all of these factors, which means that there's some significant effort should be put into developing the roadmap, defining the future energy mix, the roadmap, basically no regret moves, mature moves, transformative moves in relation to the future energy mix and future product mix of the chemical plant. And I wanted to show you a few cases for brownfields. We believe that probably one of the biggest challenges now lies in decarbonizing or reducing the fuel dependency of the brownfield facilities, existing facilities. And I just wanted to show you that you still could implement solutions and decarbonize, reduce the carbon footprint of the existing facilities. So there are a couple of examples. This one is the American petrochemical company, which we implemented the software-based solution to optimize in real time the process with what we call real-time optimization, combined with advanced process control technology. During the process, and this is what we call more mature move. The complexity is medium, investment is relatively modest comparing to the full plant refurbishment or significant technological change, and it could be relatively easily in terms of timeline, implemented in terms of timeline. So with this implementation, we've achieved more than 2% of carbon footprint reduction with the significant improvement of the fuel utilization at the plant. We managed to improve process efficiency, reduce debottleneck some processes, because also with this technology company we were able to better use their utilities for the process, not overspending fuel for the utilities, and also it allowed better visibility and manage of the downtime, reduce downtime of the plant. Similar project was implemented in the European petrochemical site, where we optimized the usage of the utilities at the plant, and with no increase, no change in the energy mix, we were able to, with the software-based solution, again real-time optimization and combined with the advanced process control, to improve fuel utilization, basically producing more product, more demanded at the market, with the better efficiency of usage fuel for the electricity production. And you can see here we've achieved more than 1% carbon footprint reduction with the relatively reasonable cost and good payback. This software-based solution, they usually demonstrate quite good ROI in the range of 1 to 4 or 5 years, depending on the plant, of course, but yeah, still good ROI. And probably last example, which could be applied in chemicals. This example is coming more from the refining and petrochemical world, but still this technology could be applied in the broader chemicals, what we call planning and scheduling for energy efficiency, and with some software which is called advanced planning and scheduling software, we are able to optimize the mix of the usage of feedstock and the planning production and product mix of the plant, to improve first of all, to achieve higher sale of more profitable products at the market, but also optimize the plant production to ensure the energy efficiency improvement of the plant. And you can see here that we've achieved 1.5% of the carbon potential carbon footprint reduction with the good payback of less than 1 year. So these are all examples of the mature technologies you could use for decarbonizing the chemical, petrochemical, and you could achieve with all of these technologies combined, sometimes you could achieve 15 to 20% of the carbon footprint reduction in the brownfield facility, meaning that you could already save and improve your carbon footprint with all existing technologies, not investing too much on the transformative initiatives, and while for the transformative initiatives, company could start doing some pilots and assessing what is the best way of basically decarbonizing to achieve net zero by 2050 or by 2060, depending on the sustainability targets adopted by the company. So that's all from our side. Thank you for listening, and of course, if you have any questions, we are ready to answer those questions.
Yes, thank you very much for your interesting presentations. Now the floor is open for questions from your side. So my colleague will provide you with a microphone.
Okay.
So as long as the audience is thinking about questions, I have one question. So you showed the 3 waves. And for the example of naphtha, I think it was, you said, or you had some numbers how long it takes. Is this somehow the average time?
It's based on our project experience, of course. It really depends on the concrete example, concrete plant. Sometimes some of the energy efficiency improvement and carbon footprint reduction measures, they could be applied during the plant downtime, plant maintenance. It could save the time on the implementation and improve the ROI. So by default, our suggestion is to use these windows of the plant downtime. But if there is no plant downtime, it could take a bit longer. But usually, no regret moves and what we call mature moves, they don't require big downtime and big refurbishment, so they could relatively easily be implemented. So it takes months to implement.
Okay.
Not years.
Okay.
If I can add, there's a lot of opportunities to address low-hanging fruits. So when it comes to brownfield projects, so we can really help our customers to lower their carbon footprint by just implementing some of our technologies, at the short amount of time, and then we can also help them identify like a roadmap for decarbonizing the entire plant. But there is definitely low-hanging fruits that can be addressed a lot shorter and get your ROI pretty quickly.
Okay.
Okay.
Good. Thank you. Other questions?
Okay.
Clear presentation.
Yes, I think so too. Thank you very, very much for being here and sharing your experiences here.